Today, we're continuing to learn all about probability, and specifically in this video, we're going to talk about theoretical probability. Let's get to it. In the previous video, we learned all about experimental probability, and that is pretty simple. You just calculate it by looking at the results from your experiment. Now, theoretical probability is different. Like the name suggests, it's the probability in theory, what you would expect to happen. It's not what always actually happens when you do an experiment. But a theoretical probability is just the ratio of the number of favorable outcomes to the number of possible outcomes. And to calculate it, it's pretty simple. The probability of your event is equal to the number of favorable outcomes, what you're looking for, divided by the total number of possible outcomes. So basically, a theoretical probability is based on what you would expect to happen, whereas an experimental probability is based on what actually happened in your experiment. All right, hopefully all that makes sense. Let's move on to our first example. All right, example 1. You randomly choose a card from the group. What is the theoretical probability of choosing a face card? All right, well first, what are face cards? A face card is a card that has a face on it, just like that. So if you look here, the face cards are the Jack and the King. Okay? Queen would also be a face card, but there's no Queen here. So with that, now we can calculate the theoretical probability. So the probability of the event is the number of favorable outcomes over the number of possible outcomes. So for this one, probability of a face card is going to be equal to the number of face cards, well, which is 2, divided by the total number of cards, because each card is a possible outcome. And how many cards are there? 1, 2, 3, 4, 5, 6, 7. So the theoretical probability of choosing a face card is 2/7, or about 29%. Let's try another example. All right, example 2. On the popular game show Wheel of Fortune.
Oh, okay.
Nice solve.
Oh, that'd be a good idea, yeah.
Mythological hero Achilles.
I can't accept that.
Okay.
Shelby.
I'll solve.
Yeah.
Mythological hero Achilles.
Yeah, that's it. Oh, boy, well.
The theoretical probability of spinning a bankrupt is 1/12. If the wheel has 2 bankrupt sections, how many total sections are on the wheel? All right, so on this question, basically they're giving us a theoretical probability, and we're going to use that not to make a prediction of what might happen in the future, but we're going to use it to help find missing information. And in this case, the missing information is how many total sections are on the wheel. So to do this, multiple different ways on how you can find that out. We could do a ratio table, we could do some algebra, but I'm just going to set up a proportion. So our theoretical probability of going bankrupt is 1/12. That's going to be equal to, well, that 1 in the numerator, that represents the favorable outcomes. So 1 bankrupt out of 12 sections is what that would basically mean. 12 total outcomes. But we know that there's actually 2 bankrupt sections. So 1/12 is going to be equal to, there's 2 bankrupt sections, so that goes in the numerator, our favorable outcomes, divided by the total number of outcomes, which is what we're trying to find. Let's just call that S for sections. So 1/12 is equal to 2 over S. This one's pretty simple. Again, you could do some algebra if you want, but I'm just going to use some mental math. To get from 1 to 2, we just multiply by 2. So if I do the same to the denominator, 12 times 2 will give me 24 total sections on the Wheel of Fortune. Which is true, by the way, if you want to double check me. All right, here are some to try on your own. All right, here's our last example. You spin the spinner 50 times and the table shows you all the results of those 50 spins. So part A says, what is the theoretical probability of spinning a red? Well, for theoretical probability, we don't need to even look at those results. We just need to look at how many favorable outcomes are there and what are the total possible outcomes. So The favorable outcomes would be red, and there's only one red section, so that's 1, pretty simple. And then the total outcomes, well, how many sections are on the spinner? And that's 5. So our theoretical probability of spinning a red is 1/5, or 20%. Pretty simple. Let's move on to part B. So part B, now we need to find the experimental probability of spinning a red. And for that, we do need to look at the table and the results. So for the experimental probability, how many times did the spinner land on red? And if we look at the table, it was 13 times. And then, so that goes in the numerator. And in the denominator, how many times did we do the experiment? Did we spin the spinner? And if you remember, it was 50 times. So the experimental probability of spinning a red is 13 out of 50, which is really easy to change into a percent. Just times it by 2, which is 26%. All right, so now we've got our theoretical probability of spinning a red, which is 1/5 or 20%. Experimental, though, is 13/50 or 26%. So they're slightly different. Let's move on to part C. So part C says compare the two probabilities. The experimental probability was greater than the theoretical probability. And you might be thinking, well, why would that be the case? And you have to remember, the theoretical probability is theoretical. It's what you would expect to happen, but it's not what always happens. This is why casinos exist in the first place, or the lottery. So when we compare, we would say that the experimental probability is greater than the theoretical probability. And what might be a reason for that? Just luck. Just luck. It happened to land on red more often than we expected. So part D says we spin the spinner 100 times. Compare the experimental probability now at 100 times compared to what we got in part B. So if you look at the table now, the experimental probability of landing on red is now 21. It landed on it 21 times out of, it's not 50 anymore. Remember, now we spun the wheel or the spinner 100 times. So the experimental probability of landing on red is now 21 over 100, which is easy. That's 21%. Interesting. So now let's compare that to the original experimental probability, which was 26%. But that was when we only spun it 50 times. Notice the experimental probability is getting closer to the theoretical. And the reason for that is because we did more trials. We spun the spinner 100 times instead of only 50. So in conclusion, the more trials you do for your experiment, the closer your experimental probability should be to your theoretical probability. All right, here's a few more to try on your own.